Hi listeners, you're welcome to another segment of our online tutorial class from your favorite student ScoreBooster, your online tutorial provider on UTME, WAEC, NECO and NEPTIB exams. For today's presentation, we shall be discussing the concept of Prayer's Law. I am Bangbade. Now, before we proceed, we need to consider the learning outcomes of this presentation, which goes thus. At the end of this presentation, listeners should be able to state Prayer's law. Listeners should also be able to state the mathematical expression for Prayer's law. And lastly, they should be able to solve relevant UTME questions relating to Prayer's law. Prayer's law states that the pressure of a fixed mass of gas at constant volume is directly proportional to its absolute temperature in Kelvin. I repeat, Prayer's law states that the pressure of a fixed mass of gas at constant volume is directly proportional to its absolute temperature in Kelvin. Mathematically, pressure P is directly proportional to temperature T. So if we introduce the constant of proportionality, we have P equals KT. We can make K the subject by dividing through by T to get K equals P over T. K in this case is the constant of proportionality, while P is pressure, while T is the temperature in Kelvin. Now, when we have more than one pressure and one temperature, then the constants for the initial pressure and temperature will be expressed as K1 equals P1 over T1. And also for the second parameters, we have similarly K2 equals P2 over T2. If K1 is equal to K2, then we arrive at P1 over T1 equals P2 over T2. This formula P1 over T1 equals P2 over T2 is popularly referred to as Prayer's law formula. So we have to take note of this as we apply it in subsequent calculation we will be meeting later. Now on to sample questions from UTME. And the first question we shall be considering comes from 1978, number 20. And the question goes thus. A gas at pressure P Newton per meter square and temperature 27 degrees Celsius is heated to 77 degrees Celsius at constant volume. The new pressure is dash. So option A here is 0.85 P Newton per meter square. Option B is 0.86 P Newton per meter square. Option C is 1.16 P Newton per meter square. Option D is 1.18 Newton per meter square, while option E is 2.85 P Newton per meter square. Now on to solution. The first step, as usual, is to write out the given parameters. And from the question we are given the initial pressure P1 to be P Newton per meter square. Similarly, we are given initial temperature to be 27 degrees Celsius, which is equivalent to 300 Kelvin. Of course, to convert temperature in degrees Celsius to Kelvin, we add 273 Kelvin. So at 27 degrees Celsius will be 27 plus 273, making 300 Kelvin. Then the pressure 2 is not given. Of course, that is what they want us to find. And the temperature 2 is 77 degrees Celsius. which similarly can be converted to Kelvin by adding 273. Therefore, 77 degrees Celsius will be equal to 77 plus 273 Kelvin, and that is equal to 350 Kelvin. So our T2 now will be 350 Kelvin, while our T1 is 300 Kelvin. Now the next is to proceed to the Prayer's law formula, which is P1 over T1 equals P2 over T2. So we substitute our P1 is P Newton per meter square over T1, which is 300 Kelvin, will be equal to P2, which is unknown, over T2, which is 350 Kelvin. So we can cross multiply to get P times 350 will be equal to 300 Kelvin times P2. So then we can make P2 the subject by dividing through by 300 Newton. Therefore, our P2 will be equal to P times 350 Kelvin over 300 Kelvin. So, and that will give us P2 equals 1.16 P Newton per meter square, making option C the correct answer for this particular question. The next question we shall be considering comes from UTME 1994, number 21, and the question goes thus: a motor tire is inflated to pressure of 2.0 times 10 raised to the power 5 Newton per meter square when the temperature of air is 27 degrees Celsius. What will be the pressure in it at 87 degrees Celsius, assuming the volume of the tire does not change? So we're given option A in this case to be 2.6 times 10 raised to the power 5 Newton per meter square. Option B is 2.4 times 10 raised to the power 5 Newton per meter square. Option C is 2.2 times 10 raised to the power 5 Newton per meter square, while option D is 1.3 times 10 raised to the power 5 Newton per meter square. Now on to solution. So the first step, as usual, is to write out the given parameters, and from the question we're given the initial pressure P1 to be 2.0 times 10 raised to the power 5 Newton per meter square. Then we are given also the initial temperature to be 27 degrees Celsius, which is equivalent to 300 Kelvin. Then the pressure 2 final pressure is not given, while the final temperature is given to be 87 degrees Celsius, and that will be converted to Kelvin by adding 273, leading us to 360 Kelvin. Therefore, our initial temperature is 300 Kelvin, while the final temperature is 360 Kelvin. Now, the next is to proceed to substitution of the parameters in the Prayer's law equation. And therefore, using P1 over T1 equals P2 over T2. Our P1 in this case is 2.0 times 10 raised to the power 5 Newton per meter square divided by T1, which is 300 Kelvin, is equal to P2, which is unknown, over T2, which is 360 Kelvin. Then we can cross multiply to get 2.0 times 10 raised to the power 5 Newton per meter square times 360 Kelvin will be equal to 300 Kelvin times P2. Then we can make P2 the subject of the formula by dividing through by 300 Kelvin. So to get P2 equals 2.0 times 10 raised to the power 5 Newton per meter square times 360 Kelvin divided by 300 Kelvin. And that will give us P2 equals 2.4 times 10 raised to the power 5 Newton per meter square, making option B the correct answer for this particular question. Now, the next question we shall be considering comes from 1997, number 22. UTME 1997, number 22. And the question goes thus: before starting a journey, the tire pressure of a car was 3 times 10 raised to the power 5 Newton per meter square at 27 degrees Celsius. At the end of the journey, the pressure rose to 4 times 10 raised to the power 5 Newton per meter square. Calculate the temperature, assuming the volume is constant. So, as usual, the first step is to write out the given parameters, and from the question, we're given the initial pressure P1 to be 3.0 times 10 raised to the power 5 Newton per meter square. Then we're given the initial temperature T1 to be 27 degrees Celsius, which is equivalent to 27 plus 273 Kelvin, which is 300 Kelvin. Then P2 is given to be 4.0 times 10 raised to the power 5 Newton per meter square, while T2, final temperature T2, is not given. So as usual, we proceed to substitution of the given parameters in the Prayer's law equation. So therefore, using P1 over T1 equals P2 over T2, then when we substitute our P1 is 3.0 times 10 raised to the power 5 Newton per meter square divided by T1, which is 300 Kelvin, equals P2, which is 4.0 times 10 raised to the power 5 Newton per meter square, over T2, which is unknown. Then we can cross multiply to get 3.0 times 10 raised to the power 5 Newton per meter square times T2 equals 300 Kelvin times 4.0 times 10 raised to the power 5 Newton per meter square. So we can make T2 the subject by dividing through by 3.0 times 10 raised to the power 5 to give us T2 equals 300 Kelvin times 4.0 times 10 raised to the power 5 Newton per meter square divided by 3.0 times 10 raised to the power 5 Newton per meter square. And that will give us 400 Kelvin. But the answer here is expressed in degrees Celsius, and we can convert 400 Kelvin to degrees Celsius by subtracting 273 Kelvin from it. Therefore, 400 minus 273 Kelvin will give us 127 degrees Celsius, making option D the correct answer for this particular question. Now on to your practice question. The first question here for practice comes from UTME 1980, number 33. And the question goes thus: if the volume of a fixed mass of gas is kept constant, the pressure of the gas is A. inversely proportional to its centigrade temperature, B. inversely proportional to its absolute temperature, C. directly proportional to its centigrade temperature, D. directly proportional to its absolute temperature. Then the second question here for your practice comes from WASC 1994, number 13. And the question goes thus: the pressure of air in a tire is 22.5 Newton per meter square at 27 degrees Celsius. If the air in the tire heats up to 47 degrees Celsius with the volume remaining constant, the new pressure is A. 21.10 Newton per meter square, B. 24.00 Newton per meter square, C. 39.07 Newton per meter square, D. 45.00 Newton per meter square, E. 97.25 Newton per meter square. So the expected answer here for question 1 is D, while question 2 is B. Now our next video will be on general gas equation with sample questions and solution from UTME. I urge you to please subscribe to our YouTube channel, like and share our videos, as we promise to be providing you with more interesting lectures on subjects relating to UTME and WASC. Thank you.